Let's see what are the cases of overfitting and underfitting in decision trees. Before looking at the cases from the decision tree point of view, let's try to understand overfitting and underfitting in general. Overfitting usually refers to the complex models, okay, and underfitting usually refers to the simple models, okay. So what are complex and simple models? So in the case of overfitting, the model becomes too complex that it cannot generalize well for the test data points. That is, when you compute the performance of the model on training data set, we often get to see very high performance. But if we compute the performance of the same model on the test data set, we often see the less performance. That is the case of overfitting. That is, the model is very well fitting on the training data set that it was not able to make better predictions on the test data set. Similarly, in the case of underfitting, we'll be having the simple models. That is, if we compute the performance on the training data, so on the training data itself, we see less performance. That is, the model is too simple to learn anything from the data. Okay. In that case, we say that the model is underfitting. Sometimes we also refer overfitting to high variance and underfitting to high bias. So what are high variances and high biases? So let's say you have the training data here. Okay. We have the training data. Okay. So if we modify, let's say, if we modify the training data a little, let's say we modify the training data a little. If we modify the training data a little, then it causes the model to change drastically. It causes the model to change drastically. Model changes drastically. So that is what refers to overfitting. Even if you change the training data a little, the model will change drastically. That's what the case of overfitting and high variance. Okay. Whereas in the case of underfitting, we are referring it to as high bias. So high bias usually happens with the simplified assumptions of models. Okay. Now let's try to look at the same things from the decision tree point of view. So when does a decision tree overfits? When we keep splitting the decision tree until each node becomes 100% pure. So what is a pure node? When all the samples in a node belongs to the same class, we refer to that as a pure node. In this example, this is a pure node where all the samples belongs to the positive class. And this is also a pure node where all the samples belongs to the negative class. Okay. And typically, we often observe the high depth decision tree in the case of overfitting, and we often see the low depth decision trees in the case of underfitting. Okay. So in the case of overfitting, if you observe this tree, so I just started from the root node and I just keep splitting this decision tree until each node becomes the pure. This case often ends up with a very high depth decision tree. So what happens when you have a very high depth? The rules or the decisions that you have in between these nodes become very complex. Okay. Let's say we constructed this tree from the training data set. Okay. Let's say we constructed this tree from the training data set. Now, if we compute the performance on the training data set, if we compute the performance on the training data set using this tree, we get 100% accuracy. Okay. Because this tree is overfitted very well for the training data. If you use the same tree to compute the performance for the test data, you don't get 100%. You get something like it can be 80% or 70% depending on the data. But you often see less performance than the training performance because the model is overfitting. That is, you have a complex decision tree. That means the whatever decisions you have in between are very complex, or complex chain of rules, chain of if else conditions. So whenever you wanted to make prediction for a new data point, you need to we need to pass that data point through a complex chain of conditions, something like, let's say, if condition 1 and condition 2 and condition 3 so on up to condition n. So the point should satisfy all these chain of conditions. So it's like a very complex chain of rules. So this is what a complex model in terms of decision trees, which usually refers to the high depth decision trees, okay, where the performance on training data will be very high and the performance on test data will be less, okay. If we look at the same thing in the case of underfitting, if we build, a single level of decision tree, that's an example of an underfitted decision tree, okay. Usually the low depth decision tree causes the model to underfit, okay. So this is like a simple model, right? It's just a one depth decision tree, which is a very simple model. So what does it refers to? It's just nothing but a single feature split, just a single feature that is splitting or at some value v1, okay. So whenever a new data point comes, we just don't care about the remaining features. We just only care about the features that we have in the root node. So depending on this condition, either that point falls under this node or this node. If the point falls under the left-hand side node, we say that this is the positive point with 60% probability. If the point falls under this right-hand side node, we say that the point belongs to the negative class with 60% probability. So in this scenario, if we compute, the performance on the training data using this simple model, it's obviously we often see, the very less performance. And also there is a special name for the decision tree with depth is equal to 1. So that is called decision stump. So decision stump refers to the decision tree with single level. Okay. So often the low depth decision trees causes underfitting models, high depth decision trees causes overfitting models. Even, this depth is a hyperparameter in decision trees. That's why we need to find the better depth value, something that's between high and low. We can tune this hyperparameter depth. This is the hyperparameter decision trees which we can tune to get the optimal value such that the model neither overfits nor underfits. Thank you.